Welcome to the fourth part in this IGCSE chemistry warm-up video for the second paper in 2018. We're going to flick all the way through to where we left off. And here we're going to go. So this question is taken from a very old paper, and actually reaction 2 and reaction 3 aren't on the syllabus anymore. So you can ignore those, but you most certainly are able to answer. Draw the displayed formula of ethene. So it's important you remember that it's ethene, so it's an alkene. And you'll have a double bond between the two carbons. It's eth, so it's only got two carbons, and the rest of the bonds are going to be made up with hydrogen. So it'll be C2H4. Obviously you wouldn't write C2H4 in the exam because that's the molecular formula. Now the other reagent needed in reaction 1, turning ethene into ethanol, and that's water. Now it's not asked us to name it or write the formula, so you can do either. So I'll write down H2O, and the conditions needed for this reaction, repeat from an earlier question, but you need 300 degrees C, 70 atmospheres, and a catalyst of phosphoric acid, which has the formula H3PO4, and that should be a 4. Okay, over the page. So what type of substance is C12H22O11? Well, that's actually sucrose, but it's a sugar. You could also answer that it was a carbohydrate, if you could actually spell carbohydrate. And what type of reaction is used to make ethanol from sugar? Well, it's a fermentation reaction. Which is a type of decomposition. State the type of reaction occurring in reaction 2. It's not on the syllabus anymore, so we can ignore it. Okay, this reaction is, or this reaction, this question is clearly all about enthalpy, and enthalpy being a rather fancy chemistry word to describe heat energy. Now here we're asked to complete the energy level diagram, and you have a choice on whether the energy level of the product should be below, somewhere down here, or above. And so you need to consider whether this is an exo or an endothermic reaction. And you should recognise the reaction as a combustion. We've got a fuel reacting with oxygen, so a combustion reaction is always exothermic. So the reaction is going to be below, and it's important that you label with the specific products. So we've got CO2 and H2O, and we've got two of those to match up with what's in the equation. Now in the next part of this question, part B, you have to work really, really hard for your marks. And I think it's important that you draw out the structure of what you're starting with and with what you're finishing with. So you start with methane, which is CH4, and you have oxygen, and you have two of those, and you make CO2, and you make water, which is oxygen bonded to hydrogen, which is also bonded to hydrogen. Now you also make two of those. So you've got to consider the bonds that you break at the start of the process and the bonds that you make at the end of the process. So at the start of the process you break 1, 2, 3, 4 carbon-hydrogen bonds. So let's write that down here. So 4 CH, and you also break 2 oxygen double bonds. Now I wouldn't set it out quite like this if I was doing the question itself. I'm sort of hindered by the computer program I'm using, but I would make it far clearer what I was doing. I'd definitely highlight bonds broken and bonds made. Here on the right hand side, sorry, I realise you can't see what I'm pointing at when I say here. On the right hand side here we're looking at bonds which have been made. So here we've made 2 carbon-oxygen double bonds. And we've also made 2 oxygen-hydrogen bonds. But we've got 2 molecules of water, which means overall we'll make 4 oxygen-hydrogen bonds. So, when we're looking for bonds broken, and this is going to be bonds broken, we're going to have 4 lots of carbon-hydrogen, which has a bond enthalpy of 412, plus 2 lots of oxygen, which is 496. Okay, and that comes to the grand old total of 2640. Now work out the energy released when the bonds are made. So bonds made, we've got 2 lots of carbon-oxygen double bonds, so that's 2 times 743. And 4 lots of 463, which is the energy released when oxygen-hydrogen bonds made. And so if you do the maths there, you have a grand total of 3,338 kilojoules being released. So overall, delta H is bonds broken minus bonds made. So we've got 2640 minus 3338, and that gives minus 698 kilojoules per mole. Now, when you're checking your answer, consider whether you're expecting a negative number here, and in this case we should have done, because we know it's a combustion reaction, so we know we're going to end up with less energy than we started because it's been released in the form of heat, so we were expecting it to be negative, and that number seems reasonable. This question looks at the allotropes of carbon. So state the term used to describe different forms of the same element in the same physical state. That word is allotrope. I can actually read my own handwriting, which is quite unusual. And if we're going to name and describe the bonding in diamond, well, diamond forms a giant covalent structure. So the bonds present are covalent. I think it would definitely be worth mentioning it's a giant structure. And I think it would definitely be worth mentioning that each carbon atom is bonded to 4 others. and you might even include the shape which is formed around the carbon. So you might say it's in a tetrahedral shape. And diamond is incredibly hard, which is why it's used for drill pieces. And the question here is now referring to, it wants you to talk about the giant covalent structure. So diamond and graphite both have high sublimation points. Explain why. You could say that they're giant covalent structures, and I think it might be worth saying that each atom is covalently bonded to other atoms, and that covalent bonds are strong and lots of energy is needed to overcome them. This question looks at ammonia and the production of nitric acid. Now the production of nitric acid is no longer on the syllabus, so we can actually ignore part B, and here we're just looking for some straight knowledge recall really. Name the raw material from which hydrogen is obtained. Well, from that you could have two raw materials. The hydrogen is made from the reaction of water with natural gas. The actual chemical in the natural gas is methane. So we're now going to write a chemical equation to show how hydrogen is obtained here. So methane and water come together to make hydrogen. And what's the other chemical which is formed? So you might be having a bit of this is difficult, and I wonder whether this would actually be asked these days. But the other chemical is actually carbon monoxide. And it's important that you balance that equation. So on the left hand side we've got 6 hydrogens, so maybe let's have a look at putting 3 on there to balance that up. And actually that works quite nicely because you've got 1 oxygen, 6 hydrogens, 1 carbon, 1 carbon. And again, the next question is a knowledge recall question. Name the catalyst used in the production of ammonia. Again, please use the word rather than the symbol because it is iron. And obviously, well, not because it is iron, but because in the question it says name it. So don't put the symbol in.